As always, it's my pleasure to introduce our speakers for the chapter meetings. I'm extremely pleased that really there's a lot of people over the last year have without any not much prompting, have agreed, or no prompting at all. Have just said, sure, I can do a talk for you on that. And it's greatly appreciated by me and our membership and others who join us, I'm sure, from very varied places, as we mentioned earlier. In any case, our speaker tonight is Dr. Zachary Singer, who's a research archaeologist at the Maryland Historical Trust, which is based in Crownsville, Maryland in the US. Dr. Singer did his BA at the University of Maryland, College Park, and an MA and PhD at the University of Connecticut. And he's held adjunct faculty positions at Towson University and Washington College in Maryland. And he has worked for CRM in private firms, so he's done a bunch of research as well as CRM work. Zach has particularly specialized in his research on the earliest human occupations in the Middle Atlantic and Southern New England region, and he's published several articles on his work at several important paleo sites and co-edited an issue of the Paleoamerica on some of these sites in the area and so on it. And his PhD, of course, concerned these occupations. And in his PhD, he even exposed an error I had made in what I thought was one of my best published papers, but I haven't held that against him on that. In fact, I'm glad that somebody recognized there was an error there. But anyway, not surprisingly, of course, he's going to talk to us tonight about some of his paleo research, an important Paleoindian site that he investigated in Connecticut, the Templeton Site. And so without further ado, I'm going to turn the podium and Jim can turn the share screen over to Dr. Singer.
So yeah, thanks again, Chris, for inviting me. I'm really happy, as always, to talk about Paleoindian stuff. It rattles around my head all the time, so it's nice to let it out every once in a while. And thank you all for coming on a Thursday evening to hear me talk about a place that's kind of far afield from Ontario, but nevertheless, there are similarities with some of the Paleoindian things that I'll be discussing. So as Chris mentioned, I'll be talking about the Templeton Paleoindian site, which is a deeply buried Paleoindian site in Western Connecticut. And the people who have helped me the most with collating this data and getting this project off the ground are Cosimo Scarlata and Brian Jones. And Cosimo is a professor at Western Connecticut State University, and he, over the last 4 years, has run a field school at Templeton, which has really provided a lot of boots on the ground doing excavation at the site. And Brian Jones is the late state archaeologist of Connecticut and a great mentor and an advocate for getting back out to Templeton. And we wouldn't be there without his encouragement. So they were both really helpful. And as you can see, there are many institutions in Connecticut and further afield that have come and helped at Templeton. So by providing excavation equipment or providing volunteers during different field days. So all of these institutions and organizations have really facilitated the work at Templeton. So I thank and acknowledge all of them. Before I get into my discussion of Templeton, having John and Chris both on this Zoom, I thought this was a perfect time to tell a quick story. So in 2010, I got into graduate school at the University of Connecticut, and I knew I wanted to study Paleoindians, but I didn't really know what studying Paleoindians in an academic fashion was like. So I was doing some research on the internet, and I found this book, Eastern Paleoindian Lithic Resource Use, edited by Chris and John. And I was trying really hard to find a copy so I could read it before graduate school started. And there weren't many available in 2010, but I found one at American University. And I drove into DC from Maryland. I was able to check the book out, and I photocopied every page of it and read it before graduate school. And this was kind of my first introduction into what academic studies of Paleoindian archaeology are. And so I thank John and Chris for editing this volume all the way back in 1989. And it had a really big impact on me and kind of showed me that I could study Paleoindian archaeology, and now I've made a career out of it. So thank you both. Getting into the Templeton site, here you can see a collection of Michaud-Neponset fluted point sites in the New England Maritimes region. So for people in the Eastern Great Lakes, Michaud-Neponset is like barns, so barns-like points. So they're, as you can see in the top right of this image, they're fully fluted points that tend to be fish-tailed or eared. So you can see examples from Dutchess Quarry Caves in New York, and also the Intervale Point from New Hampshire. So full flutes and eared points. The Templeton site you can see in Western Connecticut, that's the one that's starred. The other sites around the region also have similar fully fluted points. The radiocarbon dates, those are uncalibrated, are around 10,200 radiocarbon years before present, which calibrates to about 12,000 calendar years. So middle Paleoindian sites. Before we get into site-specific archaeology, I want to talk about kind of placing these Paleoindians on the landscape. And so thinking about the environment 12,000 years ago, fortunately, Paige Newby and colleagues conducted a large study of examining pollen cores from bogs. And one of their time periods is 12,000 calendar years ago. And so by looking at the distribution of these pollen percentages, we can reconstruct what the New England Maritimes region might have looked like 12,000 years ago during the middle of the Younger Dryas. So looking at the sedge pollen, which is the upper central image, you can see there's a high concentration of sedge in northern Maine and the Canadian Maritimes. Looking at the pine pollen, or sorry, first spruce, so top left, spruce pollen, you can see it's mostly concentrated in Maine, Vermont, and New Hampshire, and then into Massachusetts. And then the pine pollen, which is the bottom right image, is highest concentrations in southern New England, so Connecticut, Rhode Island, and southeastern New York. And so that distribution of sedge to spruce to pine is likely showing what would be like a subarctic, similar to subarctic regions, likely a latitudinal cline from more open environments in northern New England to spruce parkland in southern Maine, Vermont, and New Hampshire, and then probably a closed boreal forest in southern New England. And looking at modern analogs of what those subarctic environments are like, that would have likely influenced long distance migratory herds of caribou to move around the region. So they would be summering in the northern parts of New England Maritimes and then dispersing into the forests of southern New England to overwinter. So placing Templeton on this landscape, it's likely in a closed boreal forest environment where if there was big game hunting of caribou, it would be in dispersed populations that were in the forest, probably in the winter. All right, getting to the site, here you can see the location of Templeton. The Paleoindian occupation is primarily within this, what I have a red circle just to kind of highlight it. The site location is really great and somewhat uncommon for Paleoindian sites in the New England Maritimes, not because they don't exist, but probably because they're hard to find, and I'll explain that in a minute. But it's a deeply buried Paleoindian site, so it's on an in an alluvial setting where you can see a small kind of feeder creek leads into a larger river. So Templeton was found by Dr. Roger Moeller when he was the research director of the Institute for American Indian Studies. Dr. Moeller, which is right nearby, it's like 5 miles away. So Dr. Moeller wanted to run a local field school while he was the research director and was primarily interested in studying late archaic occupations. But what he wanted to find was a late archaic site that was intact. So would have some sort of stratigraphy. So looking at an alluvial setting where there's a chance for buried features from the late archaic. And so Dr. Moeller had seen collections from when this area was a farm field, and people had collected some artifacts, including late archaic points. And so he thought this was a great place to excavate below the plow zone to hopefully find intact late archaic features. So in 1977, Dr. Moeller organizes a large excavation with local volunteers, and they start excavating at Templeton. And sure enough, they find that the site's in an alluvial setting with that is deeply stratified, and there are intact features from the late archaic below the plow zone. But doing his due diligence, Dr. Moeller continued to excavate down below surface to see what further artifacts or occupations might be at the site. And I think it's within the first week or 2 weeks that around a meter below surface, they pulled up a fluted point or a fluted preform, which I'll show a picture of in a little bit. So with that discovery of this fluted preform, of course, there was a lot of excitement, and then the concentration in terms of what the research agenda was at Templeton switched from mainly documenting the late archaic site to trying to expose as much of the deeply buried Paleoindian component as possible. Here are the results of Dr. Muller's excavation. So he excavated 75 1.5 by 1.5 meter units. And those excavations didn't have internal provenience. So the squares were 1.5 by 1.5. So looking at distribution maps for Dr. Muller's excavation, that's the level of data that we have. But you can see by plotting the Paleoindian chert, which is the chert that's deeply buried at the site, below 60 centimeters below the surface, there looked like there were multiple hot spots. And Dr. Muller screened with 1/4-inch mesh. So this is the bigger artifacts that were recovered, not micro debitage. So multiple areas of hot spots with fluted point production debris. And I'll show you what some of that looked like. Here is some of the fluted point production debris that Dr. Muller excavated. If you've read his original publication, 6LF21 on Templeton, he discusses this material, and he discusses the raw material as being from a local source, likely from cobbles. But as John Lothrop could attest, studying Paleoindian sites, especially in Eastern New York, there's a lot of Norman scale chert. And I had become familiar with this raw material by visiting John at the New York State Museum and going on tours of West Athens Hill and other Norman scale chert outcrops. So when I initially visited the Institute for American Indian Studies to examine Dr. Muller's collection from Templeton, I told Dr. Muller, I said, this material looks indistinguishable from Norman scale chert. And I asked him more about the local cobbles that he thought the material was coming from. There were some siltstone cobbles, but the material that had been collected from the stream, in my opinion, did not match the raw material that the Paleoindians were using at Templeton. And just for time's sake, I didn't include it, but there's been a thin section study has been conducted comparing the Templeton raw material to Norman scale chert and the local siltstone cobbles, and the material at Templeton is clearly Norman scale chert. So it's coming from southeastern New York. Okay, nevertheless, this at Templeton, there's a lot of fluted point production debris that Dr. Muller recovered of this Norman scale chert. Some interesting things you can see. Hopefully that circle popped up. There are, to the right in the circle is an overshot tip of a fluted point. So during the fluting production, a flute that was going the full face of the point continued traveling and took the tip off. Probably not an insurmountable failure. They could have resharpened what's left of a long biface. And then to the left of that, you can see another snapped tip. And this one has what Chris Ellis has described as it's got that tongued appearance. So it's isolated, perhaps, and it's not a sharp point, right? It's got a flat tip at this point. So likely to help facilitate this full fluting, whether it's instrument assisted or not, it probably is. And then in the middle, you can see the fluted preform that Dr. Muller recovered in 2 fragments, which was the big tip off that this was a Paleoindian site. And that fluted preform, you can see the ears, right? So it's wasted and eared, even though it's not finished. And it's got a flute extending up a good way on the point. And then in the bottom row, these are base fragments that were broken during fluting. So you can see the one in the center has a nipple platform that hinged like crazy, and the one to either side of that, you can see the flutes, but snapped when the reverse face was attempting to be fluted. So a lot of fluted point production debris in Dr. Muller's assemblage. When Roger had analyzed the site, he had noticed these materials, and he had noticed a handful of channel flakes. But one of the things I did for my dissertation was to do a full study of the debitage in great detail and examine each flake. And I was able to identify 164 channel flake fragments, which we then, me and some of my colleagues, conducted a refitting study, which was really fun. So we labeled and oriented all of the channel flake fragments and put them all out on a table and had a really fun 12,000-year-old jigsaw puzzle. So here you can see some of the refits, including the one, you can see it says 7 centimeters. So that's the longest refit set that was reconstructed. None of these channel flakes are completely refit. So the channel flakes could be even longer than that, and likely they are. So based on Dr. Moeller's assemblage, I did some of this fun math that Chris Ellis published with Payne in 1995 to try to estimate how many fluted points had been produced at Templeton. Rough estimates, probably underestimates for sure. So if we look at the proximal fragments, so just the striking platforms, and we say that each fluted point was fluted once per face, so divide by 2, then there was something like 18 fluted points made in the assemblage that Dr. Moeller excavated. And if we look at the total lengths of the channel flakes and compare it to the average channel flake length at Park Hill, it's somewhere around 23 fluted points. So in Dr. Moeller's assemblage, we can estimate somewhere around 20 fluted points were produced. And that's the majority of the material. So biface production debris and channel flakes. There aren't complete fluted points. There aren't other scraping tools, end scrapers, side scrapers. There were a few gravers. That's the assemblage that Dr. Moeller recovered. So while I was analyzing in Templeton, I was coordinating with Dr. Moeller, and he would visit me and we would discuss my reanalysis of his collection. And he mentioned that, he said, the site's right down the street and it's probably still intact. We should go there and see if we can talk to the landowners. So we did, and the landowners were very gracious and hospitable and said, you all want to come back out here and do more work? When we bought this property, we had heard about the Templeton site, and we've been hoping and waiting for an archaeologist to come visit us to see if people could come back out here and study the site in more detail. So was really gracious, and in 2016 we organized the first return to Templeton. On the left you can see Roger's map from his 2 excavation years. So Roger didn't dig shovel test pits at Templeton. He started a big block excavation and just continued expanding on it. So I asked him, perhaps could there be additional activity areas that weren't found? And so when Dr. Moeller was excavating in the 70s, this idea that there could potentially be many different loci separated in space hadn't really been formalized yet. And so by reading things, particularly by Chris Ellis and John Lothrop, I figured I should come back out here and try to find additional activity areas. And so that's what we did. But the first thing we did, and again, getting back to Dr. Brian Jones and his support on this site, was we had to reconstruct Roger's grid. Of course, after 30 years, the datum that Roger Moeller had used was no longer visible. So what we had to do is try to figure out where his excavation actually occurred. And I give Brian all of the credit for doing this. He took an auger and cored around until he found intact soil and then disturbed soil and kept narrowing it down until eventually you can see here, we found one of the corners of Dr. Moeller's 1977 excavation. And from there, we guesstimated where the next corner would be, which we found, and then a third corner. And from there, we triangulated and now had Dr. Moeller's excavation on grid, which we could build off of for our current excavations. So we started with shovel testing. Most of the shovel test pits were 50 centimeters by 50 centimeter squares. The one in the picture to the left looks a little funny, but that's because they hit something right below the plow zone, so they kind of shifted it. So it's not really as big as it seems, but it is as deep as it seems. So this is a deeply buried alluvial setting. The Paleoindian occupation occurs right above a cobble layer, which could be glacial till. So typically in these shovel test pits, we're digging 50 by 50 centimeter squares down at least a meter. Here's an example where the test pit went 1.50 meters. And one of my favorite things to do while people are volunteering to dig test pits is they dig about 80 centimeters and they say, I think we're done. And I say, did you hit any cobbles at the bottom? And they say, no. And I say, well, then you're not done. So we continue down, and we've even been gifted things like that huge shovel in the picture on the left, which is for planting telephone poles. But it's very useful because it's got a scoop at the bottom. And so for getting the soil and potential Paleoindian material culture out of these very deep 50 by 50 centimeter test pits, it was very useful. And what we were finding in these, all of the test pits and all of the excavations that I've conducted at Templeton are using 1/8 inch mesh. And so this test pit survey was mostly looking for evidence of Paleoindian activity areas. So anything below 60 centimeters below surface that yielded chert. Here you can see some chert flakes in the screen. That was what we were keying on and getting excited about in these test pits. Here is the result of the test pit survey overlaid with my excavation blocks, which I'll talk about in more detail. So we excavated in 4 meter intervals across good chunks of the site. We didn't go right up to the edge of Dr. Muller's block in some areas, so it's kind of bracketed a little bit. But this is the distribution of chert and jasper at 60 centimeters below surface or deeper. And you can tell there are multiple areas where we found at least a handful of chert flakes below surface, if not 40 chert flakes in a 50 by 50 centimeter square. And then 2 in block E were over 100 chert flakes at depth. So based on that test pit survey, we've been opening up excavation blocks, again, with Western Connecticut State University's field school and many volunteers from all those organizations that I showed in the beginning. And what this work has shown is there are potentially at least 13, there were potentially at least 13 activity areas. So 3 in Dr. Muller's excavation based on the concentration of chert flakes. And then based on our test pits where we had the artifacts at depth, those are potential, based on the stratification of the site, potential Paleoindian activity areas, many of which have been confirmed with additional excavations over the last 5 years. And I'll talk about this in more detail, but out of the places that we have tested with block excavations, 8 of those areas are fluted point production areas. And if you'd seen me give this talk a couple years ago, I would say they're all fluted point production areas. That's all we have evidence for, is making fluted points. But we finally found our first uniface resharpening activity area. So a little different pattern. So before I get into the artifacts, I want to talk briefly about the site formation processes. So how did this site get deeply buried? Here's a profile that you can see from 2019. So the top, you see the plow zone, and then different bedded sands with depth. And the Paleoindian artifacts are, if you look at the bottom right, you can see a cobble kind of sticking up on the bottom, the base of the excavation. So the Paleoindian occupation is occurring right above that cobble layer. And then as we kind of pry the top cobbles off, sometimes there are artifacts that have worked their way in, but probably through settling. And then there's been 12,000 years of sedimentation on top of that, with archaic artifacts. Mostly there's middle archaic, a little bit of middle archaic, and then there's a good late archaic occupation right below the plow zone, and then some woodland artifacts in the plow zone. So to get a better idea of the sedimentation at Templeton, my colleague Dave Leslie and Will Wiemet, my colleagues from UConn, have been pioneering this idea of using vibrocores, which are typically used in swamps, but they super saturate the sandy sediment and then kind of ride it like a bucking bronco to get the sediment samples, to get the tube to penetrate the sediment and collect full soil cores, sediment cores. So it was really cool and really successful. So here you can see one of the cores cut open, and you can see a quartz flake, probably from the late archaic, below the plow zone. So we even got an artifact in one of these cores. We took them on we took 4 vibrocores, kind of moving our way inland from the major river at the site. So to look at the depths as we move further in away from the floodplain. And we were able to get some radiocarbon dates from these cores, and TVC2 particularly, we got 5 dates, and the dates worked out great. So I was really happy about that. So the dates you're seeing on the core are uncalibrated, and then I have the calibrated with the newest IntCal 20 in the table. So the dates to draw your attention to are the bottom 2 from TVC2. So the Paleoindian, most of the Paleoindian debitage and artifacts come from the layer where that second the second from the bottom date is. So that 10,289 plus or minus 40. And then you can see the bottom date of 10,924. And you can see the core actually bent up on one of the cobbles. So we got to the bottom, which is great. And so that's dating a bit older. So like I said, there are Paleoindian artifacts that are associated with the cobbles, but most of the concentration seems to be above that and working its way down. So that date that's calibrated to 12,450 to 11,830 is probably, I think that seems reasonable for the Paleoindian occupation. But there could potentially be an early Paleoindian occupation intermixed with the cobbles, although I haven't found evidence for that yet. All right, so I'm going to get into some of the excavations in the material culture that we've recovered. So we'll start with block A. So this was, I guess I should have put where the river was. So the river is to the east on this image. So block A is the closest excavation to the river, meaning it's the deepest. And here at 106 centimeters below surface, we found an in situ fluted preform in 2 fragments. You can see they're circled in black. I'll zoom into them in a moment. But the site formation processes are similar here as elsewhere. You can see a cobble to the right sticking out. So when you first get the biggest cobbles, that's when we stop shoveling and we start troweling to try to find artifacts in good context. So here is that fluted preform again in 2 fragments, but it goes back together. This was at 106 centimeters below surface. So here's what it looks like. It's complete. You can see the tip again is not finished, it's not sharp, it's blunted. So again, perhaps to facilitate full fluting by putting it on some sort of anvil or into some sort of device. And there's a nipple preform, a nipple platform on the base, and this thing broke in half probably during a fluting attempt and was thrown away. The raw material looks macroscopically similar to Norman scale chert from southeastern New York. Other materials recovered from block A include, so the top 2 things are large, limitedly modified flake blanks. So they're large flake blanks of what seems to be Norman scale chert. What I would argue is probably what people are carrying from the quarry south of Albany to Western Connecticut. There's a graver, the top right image. And then there were other bifacial preform fragments. So the one on the left is a biface, but it's not well modified. And then the one in the center is another one of these bifaces with an isolated tongued and ground tip that snapped. Whoops, wrong way. Other things that were recovered include many channel flakes. The yellow material looks to be macroscopically similar to Hardyston Formation jasper from eastern Pennsylvania. And then the green, again, the green material, it's likely Norman scale chert. So many channel flakes, the jasper channel flakes, so the top row, second from the left, you can see it's a secondary flute. So there's another channel flake scar running along the left portion of this. So a secondary flute made out of this jasper. And some of those channel flakes have refit. You can see on the right, there's small fragments, but they refit back together. Looking at the distribution of Paleoindian debitage, we can compare the chert and the jasper. And it looks like there's probably 2 hotspots based on the chert. So purple is the highest, and then blue is the lowest. So yellow and then green are kind of in the middle. But based on the chert, there's a very good hotspot on the western boundaries of this excavation. These squares are 50 by 50 centimeter squares. So when we excavate, we're screening everything with 1/8 inch mesh. We're excavating in 5 centimeter levels and in 50 by 50 centimeter quadrants. So that's our level of provenience. So these are 50 by 50 centimeter squares you're looking at. And then looking at the jasper, it's mainly concentrated in association with that eastern chert cluster. The lightning bolts are all the channel flakes. So both of those clusters have many channel flakes, suggesting fluted point production in these areas. The refits are moving up and down a little bit. Like I said, things are probably settling into those cobbles, so that the Norman scale chert refit, one was from 110 centimeters below surface and it could be down to as deep as 140. So 30 centimeters up and down, but north and south, it's less than 50 centimeters. And then the set of three that from Jasper are showing a similar pattern. So things are moving about a meter horizontally and maybe about 40 centimeters vertically. It's sandy soil and it's been there for 12,000 years. So that's not, doesn't bother me, but it's fun to reconstruct. Block B, this is the furthest inland that we've excavated. And here, again, we're getting chert flakes. You can see a chert flake sticking out of the wall right above the cobble layer. This was when we were cleaning up the wall for a profile, so that's why it looks a little messy. Not as much in block B. There's plenty of debitage, but not as many clear channel flakes or clear fluted objects. There are these siltstone chunks. You can see the two from the left. So the leftmost two are these it's probably a local siltstone or hornfels, something like that, and it's being bashed up, so maybe being used as wedges. There's huge ripples in it. It doesn't look like it's being turned into bifaces, really. It looks like it's being used to smash or wedge. Then there's a Norman scale chert utilized flake in the center, and then there is an end-thinned preform on the right, which I'll show you in more detail. So here's this end-thinned preform. So it's the base. There are end-thinning flakes on both faces, but the thing snapped in half, and it's likely an earlier stage of a preform. But the end thinning is suggestive that and the end thinning is suggestive, and where we found it, which was deeply buried in a soil layer that tends to date to about 12,000 calendar years ago. So it's pretty suggestive that this is likely a Paleoindian preform. Here's the debitage, both the chert and the siltstone. So that similar clusters, but really one good hotspot that we came down on about 1.5 meters by 1.5 meters that we excavated to the boundaries of. There were a few channel flakes, so a few, but not nearly as many as the other activity areas. Block C, so this was south of Dr. Muller's block. Oops. Here again, another fluted point production area. These are flakes, including channel flakes that we left in situ just for a fun photo. And I give Dick Beauvert the credit for giving the idea to put our signboard numbers next to the artifacts so you can see them better. So that kind of helps. They show up pretty decent. Number 1 is a large channel flake fragment. So that's the topmost one. And again, the context is in the sands above and into the cobble layer. So you can see the cobbles to the left. It kind of slopes as you go towards the east, closer to the river. And here again, many channel flakes were recovered in one fluted preform. So here are some of those channel flakes, including a refit, a rather decent set of 4 that I refit. All Norman scale chert or green chert that looks macroscopically similar to Norman scale chert. And here is this one fluted preform fragment. So this is a pretty wild failure. So it's been fluted at least once. You can see this kind of center right image. There is probably 2 prior flutes. And then on the third one, the thing snapped in half and dove through and ripped this ear off. We excavated a lot in this area. We haven't found other fragments of this preform. So maybe one day we will, or maybe someone salvaged it or threw it further afield in disgust, but we haven't recovered it. Again, looking at the distribution, we've been there 2 years, so that's why this map looks a little funny. I need to clean it up a little bit, but many channel flakes were recovered from this excavation area, 58 channel flake fragments in one very tight hotspot, about 1 meter by 1 meter, which yielded over 100 flakes in 3 of those 50 by 50s and around 80 in another. And then it winnows out from there. So it looks like we nailed the center of another fluted point production area. Again, refits. Here are 3 sets of refits that show that of channel flake fragments that show that the materials are moving up and down in the soil about 20 to 30 centimeters and horizontally at most 1.5 meters. Another great discovery during this excavation was a carbonized twig. An archaeobotanist analyzed it and said it's likely oak. And so this was found in that chipping cluster, not in a feature, but found in association with that chipping cluster of channel flakes. There's a channel flake fragment right next to that twig that I circled in red. And so we sent that off for a radiocarbon date, which calibrated comes back to 12,471 to 11,996 cal BP. So again, somewhere during the Younger Dryas. Another interesting thing that you can see in this profile, so looking at the right image, is there are other layers of kind of larger floods that deposited cobbles there. So there are two layers that we dig through before it gets back to the sand in the Paleoindian occupation. So if we had just excavated down and hit that first layer of gravels and thought that was the glacial till, we would have been very wrong, and we would have been leaving an intact fluted point production area buried 60 centimeters deeper. So these floodplain settings can be kind of interesting, and why we try to keep pushing as deep as we can. Block D was excavated to further examine Dr. Moeller's excavation areas. So again, you can see his the Paleoindian chert count in his excavation to the right. So there were at least two hotspots you can see by the red, where over 1,500 flakes were recovered. But then to the north of that, there's another one of these orange hotspots where somewhere between 200 and 500 flakes were found. So I wanted to figure out, is this in fact a third activity area that Dr. Moeller had clipped? So we excavated two 1x1s next to his larger excavation. And sure enough, we found evidence of fluted point production. So there's a jasper preformed tip in the top left. It's kind of hard to see, but it's a tip that, again, is blunted. It's not finished, and it's snapped. We did find a graver, so that's the top second from the left. And we found some channel flake fragments, which are also shown, as well as larger chert reduction, biface reduction flakes. So that's the bottom right two, things that at least look macroscopically very similar to Norman scale chert. And this distribution map isn't very good. I mean, it's not much to see, but it looked like Dr. Moeller did hit another fluted point production area, which we also sampled. And there's certainly more intact for future investigations. Block E was excavated in 2019. So this was our last large excavation before COVID, kind of put a damper on continued research. And here you can see some people, including Mark Clymer in the background in red. So another Owlville veteran who is from Connecticut. So he visits us sometimes, which was very nice of him. So here we are plugging away. And again, like I said earlier, if you had seen me give this talk before 2019, I would say every activity area we find is a fluted point production area. And that's interesting in and of itself. And are we ever going to find an area where unifaces are being used? In most Paleoindian sites, or in many North New England Paleoindian sites, you find 3 end scrapers for every 1 fluted object you find. So it was a very different pattern at Templeton. Well, finally, we found an area with unifaces. So bottom left D, that's an end scraper. And E is some sort of longer, either a side scraper or the proximal end of an end scraper that's snapped. And then also some retouched flakes. So A is a siltstone retouched flake, and B and C are chert retouched flakes, and F is a jasper retouched flake. You can see the nibbling really well on F. So finally, we found a uniface area. But we still did find some channel flakes. So here are 3 small channel flake fragments of that green chert, which again looks mostly like Norman scale chert. And some other objects, likely wedges. So a crystal quartz piece that's been really smashed up again, but it's found at the right depth. It's found in the layer that tends to date about 12,000 years ago. And then another one of those siltstone artifacts that you can see the opposing crushing damage going from the bottom left and then up from the other end to the bottom right. So I think they're smashing up this siltstone probably as wedges. And this, I think, is a pretty good example of a PE. And another great discovery from this excavation block was a complete flake blank. Again, found in two pieces. One was found during the field session, during the field school, and the other was found during another September excavation. And Nathaniel Kitchell, who's another Paleoindian colleague, he had seen both pieces and he said, you should probably go check if those things go back together. And sure enough, they do. And the top is cortical, as is the bottom. So the platform as well as the distal termination are both cortical. And this fits really well with Chris Ellis's discussion from Thetford 2 of flake blank production. So it looks like they have this a blocky core that they're driving these full face flakes from. And with Norman scale chert, it tends to be more siliceous in the center and kind of get less siliceous as you get towards the cortical surfaces. And that's what this piece is showing, both in kind of its luster and glassiness, as well as having the cortex is really helpful. So this was a great, again, another reconstruction from Chris that was really useful to consider when studying Templeton. The other interesting thing about this artifact is you can see there are pot lids on it. So it was burned. When did that occur? I don't know, but it burned before it was broken, because there's a pot lid that's going across the break separates a pot lid. So I'm not sure what that means, but it was burned and exploded and was left at the site. So it shows, at least the least it does is show probably what raw material Paleoindians were carrying from the quarry location to Templeton, likely to then transform into fluted points. And here's an example from a Norman scale chert outcrop that I visited with John, and you can see one of those blocky cores, or sorry, not a core really, but a blocky fragment that was smashed up to sample. But you can see the flat cortex and had this blocky kind of the blocky raw material package that Paleoindians were likely exploiting, something similar to. We were able to refit a uniface resharpening flake back onto the end scraper. That was really cool. And again, so you can see on the left is with the top left image is with that resharpening flake on the uniface, and to the right is the image with that flake removed. So it was a large flake, one of the last removals before this end scraper was discarded. There were a few additional you can see based on the flake starts on the uniface resharpening flake. Additionally, during these excavations, we recovered another feature. So this was we recovered a feature, I should say. This is a soil stain. You can see it's kind of amorphous, but a small kind of basin-shaped stain. We went back in September to try to excavate and recover the rest of what was going into the wall. And of course, it went about 2 centimeters into the wall and stopped. So we got all excited for a big feature, and we had already really sampled most of it. But it was deeply buried. So this was 95 centimeters below surface. There was not very much charcoal. There was one piece. You can see the one in the bottom left image, which is showing where the charcoal was located. And you can see it in a close-up above. The archaeobotanists who examined it couldn't identify it positively, but they said that their best identification was parenchymus tissue. So we sent this off for a radiocarbon date, and it came back 10,060 plus or minus 30. So when calibrated with InCal 20, that calibrates to 11,805 to 11,398. So a little bit on the younger end. We have Paleoindian artifacts in the same layer that this date occurred. So what does it mean? I'm not sure. Perhaps it's a slightly younger dating Paleoindian site. Maybe the site's occupied multiple times, or maybe this pit is intrusive and it's from a little bit younger occupation, not associated with the Middle Paleoindian occupation. So there are many ways to kind of interpret this data, but there was a feature that yielded this date, and there are many Paleoindian artifacts nearby, is what I can say. Looking at the distribution maps for the Chert and Jasper, again, looks like there are 2 activity areas that were sampled in this large block, both of which we nailed the center of and are dying off as we expand out. So only a few channel flakes, and I would say that, and I don't have the distribution maps yet made for the biface resharpening flakes versus uniface resharpening flakes, but that eastern concentration of Chert and Jasper is primarily uniface resharpening flakes. and the western concentration, it has more biface resharpening flakes. So I think we have one uniface resharpening area, which is that eastern concentration in this block. And my refits aren't as pretty here, but what you can see is the end scraper was found in that western block, but that uniface resharpening flake was found in the eastern block. So showing that these hot spots are likely contemporaneous. And then the flake blank, again, kind of links those two areas. So they're found a few meters away from each other, I think, showing probably contemporaneous activity in these two hot spots. So that was kind of fun. I know this is really busy, but I just wanted to show where all of the radiocarbon dates have come from Templeton. So Dr. Moeller got a date in the 70s from what he described as a burned post. That's the blue date in his excavation, but it was a standard date, so the error range is plus or minus 300. I'm still hoping that somewhere within the Institute for American Indian Studies, there's additional samples of that carbon to redate with AMS, but I have not found them yet. It'll be really great if we do. So the date, when you calibrate it, is really wide, and it doesn't tell us too much. Lucinda McWeeny took flotation samples from Dr. Moeller's excavations and got a date of 10,215 plus or minus 90 from a piece of oak that she identified at somewhere around 99 centimeters below surface. So that would put it, she says it was in association with chert chipping debris, likely Paleoindian in age. So again, it's not from a feature, but it's dating that layer where the Paleoindian chipping debris is located. And then I have my two dates, which I discussed in more detail. So looking at them all together, we can calibrate them. Lucinda's date could overlap with either of my dates. Again, Roger's date, when you calibrate it so wide, it's hard to, yes, it's Paleoindian. That's what it says. But my dates don't seem to overlap. So what does that mean? It's open for interpretation. The only date that's from a soil stain in the ground is that date from 2019. So that's the younger of the dates, the 11,805 to 11,398. But when we get dates from the soil, they tend to date around 12,000. So open for interpretation, and I'm happy to hear people's opinions. So overall, again, just to summarize, based on the excavations at Templeton to date, there are 9 confirmed Paleoindian activity areas, somewhere around 11 potential areas. 8 of those areas so far that we've excavated are fluted point production areas. Lots of channel flakes, a few broken preforms. That's it. We haven't found a single complete fluted point at the site. And now we finally have one uniface activity area in Block E. I will give a teaser, but I don't have the data yet to show. But that centralmost yellow test pit standing on its own, it looks like it says it's below Block D. That was sampled by Western Connecticut State University's field school this past summer. They excavated 4 1x1 meter units, and they did recover at the Paleoindian depth a preform as well as a few potential channel flakes. But I haven't, since I'm in Maryland and it's in Connecticut, I haven't been able to analyze it yet to present. So it seems that there probably is yet another confirmed Paleoindian activity area and additional ones that are left to be investigated with further research. So what do I think is going on at this site? So thinking regionally, again, most of what's happening at Templeton is the production of fluted points. We're not seeing them being discarded. We're seeing them being produced and taken somewhere else. And so based on my original, one of my first slides, talking about the environment of the New England Maritimes region at 12,000 years ago, which was likely conducive for long distance migratory herds of caribou, I think Templeton looks to be a gearing up site where a bunch of people stopped and made fluted points, likely for some sort of organized hunt that they were anticipating. And the herd animal that could be anticipated in the New England Maritimes region during the Younger Dryas would be caribou. So my leading assumption, or my leading best guess of what's going on at Templeton, is that it's one or multiple gearing up events where Paleoindians have just recently quarried Norman scale chert, are turning those flake blanks into fluted points to go on some sort of organized hunt, likely for caribou. Where could be somewhere around the boundary of Massachusetts, where the closed boreal forest kind of starts, or perhaps they're moving further afield. The Colebrook site in northern New Hampshire has a fair amount of Norman scale chert as well. So maybe that's the other end of what would be a long distance migration. So with that, there are some people, many people need to be acknowledged. First and foremost, again, is Brian Jones, who was my mentor and colleague in Paleoindian research, and kind of opened many doors for me to conduct Paleoindian research in Connecticut, and particularly got Templeton back up and off the ground again for me to excavate. So none of this would be possible without Brian's encouragement and enthusiasm. And then the landowners at Templeton are amazing. We couldn't have asked for a better hosts. So not only do they invite us with our with field schools, but also they let us camp and bring volunteers. And you can see there are many adult beverages. They have a huge fire pit. They set up large barbecues and feed all of the archaeologists. So they're the most wonderful and hospitable landowners of all time. And that's, besides having a really cool archaeological site, it makes it really a wonderful pleasure to go and excavate at Templeton. And then all of the people who have excavated at this site. So there are, again, many volunteers and field schools from Western Connecticut State University. None of this research could be conducted without them being there to be enthusiastic and excavate and find the material culture, which I can then talk about.